Hi, welcome to myprojectbazaar.com. Now we are going to see a process of an attribute-based encryption with a Verifiable outsourced decryption in a cloud computing environment. Nowadays, the cloud storage plays an important key role in storing the data in remote servers. Being a remote server, it lacks the scalability and security issues plays a major drawback in the remote cloud storage. For that, many security solutions have been proposed in order to secure the data in a remote infrastructure service. But in our paper, so we have to enhance the data integrity process and also data security process by means of the attribute-based cryptography process. It will it will not only overcome the drawback of the identity-based cryptography, which is a previous existing solutions for the securing data in a cloud database. Also, attribute-based encryption extends the attribute set-based encryption policy with a hierarchical structure to improve scalability and flexibility that inherits the future access control of the attribute-based cryptography process. Now we are going to see the flow of this process. First, in this attribute-based data security process, the data owner has to initiate or has to store the data in a very secure manner. For that, he has to derive the access policy attribute derivations by means of the binary mapping algorithm. So after that, by means of that binary mapping process, he has to generate the master and secret key, and after that, using that secret key, finally he is aggregate by doing the AND and XOR operations. He finally generate the aggregate key. By using the aggregate key, we apply the EES encryption process and we make the data secure, and after that we outsource the data into the cloud. After outsourcing the data into the cloud, the secure private key mechanisms used for giving for the key sharing process whenever the data consumer asks the request to that cloud server. Now, once the data has been retrieved in the client side, so it has to be verified by means of the message authentication code for the integrity verification process. So in order to verify the data, we have to use the hash-based message authentication code algorithm for checking the data verification. Next, we are going to see the demo of the process. In order to run the process, we have to run the home.java. So in this file, so once you run the file, you will get the home page. Here, first we have to create the repository. Give the ID, name, user, then IP address. So you have to create the cloud repository, data owner repository, and after that you have to access. Once you acknowledge it's a valid user, you have to show the files. These are the files which has to be present in the data owner repository. Once you so for that, these are the attributes which has been extracted in size, and the cipher class index creation which has been created for the process. Then it shows the list of files to be selected for the data initiation. Then for example, I'm just selecting the PDF. So for that, I'm selecting any PDF files here. Here inside the package, you file the data owner underscore repository folder. So you just select that folder. Inside that, you can able to place any PDF or documents or any files inside here. I'm selecting a PDF file here. I'm pausing the text data or the data contents only from the PDF files, and after that give process. So here, once you give that keygen button, it will derive the attributes of the data which has been given previous. So it will say extract the name, size, and the time it was modified, and after that in order to generate the master key generations, we have to take any two attributes which has been generated before. For example, for the first time I have taken that file size and the file name. By using these two attributes, I am just do the binary mapping process by using the AND operations. Just give, when you give generate, the master key is generated, and after that so that master key will be passed to this frame, and also public key is taken from the another data owner attribute, which is make as a binary attribute here. By combining these two keys, we do the XOR operation. Finally we create the secret key here. We just have the secret key. We use the secret key for that input of this data cipher operations. We place the secret key here in order to do the. So our innovation is like, so we in the previous existing mechanism, the secret key is generated by the key instance method. Rather than we do the derivation policies for the key generation mechanism, and after the derived key is we given as an input here. By using the key, we encrypt the data, and after that we are going to upload the data into the cloud. For that, we just extract the server package, running the cloud.java. After the running the cloud.java, give repository and click store, and after that click upload button here. So data has been uploaded. Then source in your file has been received in the server side. After that, click home button, give transfer here. After that, don't click the transfer process here. So before that, you have to click the retrieve button here. Give view files. His the data owner files which is listed in his repository files have been listed here. I am just selecting the base.txt, any files. I'm just giving the request here, and after that go to the cloud transfer here, give transfer. So your download request has been validated. Once the download requests have been validated, your files are received here, and after that give process here. So your files have been validated by using this is the aggregate key you have given. So once it has been validated, you have to give the retrieve. Your encrypted data has been retrieved here. So once the encrypted data has been retrieved successfully, we have to check whether the retrieved contents are correct or not. For that, we have to go for integrity check verification process. So here our retrieved file content, here the MAC key generation is generated by using the HMAC algorithm. So before the data has been uploaded into the cloud, your integrity code is already stored in the database. For example, here already before the data has been stored in the database. For that, this way the MAC code has been generated before the storing data into the cloud. Once the data has been retrieved from the cloud, this generated MAC code and already retrieved MAC code check whether it is same or not. If it is same, means it source value. So all through the process, we have achieved the secure derived key generation policy by using the attribute based encryption. After that, the secure data has been uploaded on the cloud, and after that data have been retrieved from the cloud. The integrity verification has been done successfully. Thank you for watching.